cavalier with my job. Cool. So let's continue on. We were talking about degrees and radians yesterday, and we said, okay, degrees are just simply going to be 1/360th. And it turns out that this comes from a different idea. I'm going to give you guys 60 seconds. Don't write it out, but I want to challenge you between you and your neighbor, play a 1 out of 1 rock, paper, scissors, and whoever wins gets to decide if they're going to explain to the other person what is a radian, 1 radian specifically, or is your neighbor explaining it to you? Cool. Basil, I'm going to be your partner. Don't play rock, paper, scissors. Number 4. Who dat? All right. Wisha, what's a radian? Okay, so it is a unitless measure of a what? Not quite a circle. An angle. You could say an arc, which I think I heard somebody whisper. Maybe not very well of a whisper, but that's okay. Now, I'm going to be much more specific. A single radian. It certainly has something related to this, right? It is a way to measure angles. Here's the deal. This angle is 1 radian right here. And in like just as far as definition goes, 1 radian is the angle that it takes to form an arc whose length equals a radius. Like this picture that we've drawn, this is 1 radian. It's how we worked out that there's 1 radian here. There's, 1. Here's a second radian. I didn't draw the line, but here's the third one. And I can convince me a little bit more that this is just a little bit more than 3, and 0.14 is believable for it. There's where my pi shows up there. Now, if you want to see it really work out, the entire distance around a circle is 2 pi r, no matter what the radius is. And if I do the same calculation where I take the length of the radius over the radius, my r's divide out, and we wind up with, no matter what size circle, how many radians all the way around? No matter what size the circle is, these r's will always fall out. I'm going to find that what's the distance around a circle? 2 pi. Now, the unitless part is always super weird. If I were going to measure this, I don't care what we use, would it have been possible that my circumference had been measured in feet? Like, could I measure a radius in feet or meters or yards? It doesn't matter, right? If it had been feet, and you don't have to write this, but do you agree that I would have had feet up here? Because that's an arc length in feet. And my radius would have been measured in feet. And what happens with my units? And here's why we have a unitless measure. Because when you take a length over a length, the units just naturally divide out. There is no unit on a radian because of that. But remember, we might want to, and it's entirely up to you, but we could write radians if we want, just to keep track of stuff. Okay, now with all of that said and done, let's jump in and play around with some of these. Okay, some of you guys remembered little bits and pieces of this, and it's awesome that you did, but there's a couple different things that we need to do. We talked yesterday about coterminal angles, at least briefly. Co means together, and terminate means to what? To end. We can have 2 angles that end and start at the same spot, but go different directions. These 2 angles, alpha and beta, do exactly that. They both start here and they end here, but they're very different angles, right? If I gave you alpha, and we're going to do a better problem here in just a second, so I'm just going to use this as an example before we do the radian game. Let's say alpha was 130 degrees. How would you get beta? You do 360 minus 130, and we could get that it must be 230. Okay, now the cool thing is, conceptually, is there anybody that doesn't quite catch what I just said? What do you know a whole circle is, Lay? And if this is 130, this must be just the difference to get me to 360, right? So that's all that we did. Now, we're going to make a change here with it, because you guys naturally want to think in degrees, but maybe less natural to you, radians are so much nicer. And you probably don't agree that they're nicer to think about in your head and stuff, but I assure you any calculation that we do is going to be so much nicer if we use radians instead of degrees. Everything will be nicer. So it means that we're going to start doing some problems here. We'll just jump right in, where we're going to use some of these ideas. So a few examples, and they're going to come in a variety of flavors here. Let's check them out. Our first example is I want us to find coterminal angles. And I'm going to be more specific just so we can practice. We're going to say find coterminal angles alpha and beta. Now, the only reason I'm doing this is I can now give you an alpha, and we're all going to agree that the other thing that we find is beta, or some variation of those. So big question is, do we start with radians, or do you want to jump in with degrees first? Okay, love it. So here we go. Alpha is, we're going to say, I don't know, let's get crazy with it, pi eighths. Notice I don't have a symbol or unit on it. You do not have to write it. If you want to, you can write radians, or what I typically use is rads for short if I'm going to write it down. Now, I can't stress this enough. There's really no unit. This is just to help us keep track of it. Okay, so if this is pi eighths, could we sketch it first of all? Would it help to sketch it, do you think? At least for the first one, I think it will. So let's try. Now, the good news is that we don't have to be super precise. Bless you, I think. Bless you again. We don't have to be crazy precise with it, but we're going to draw this in what's called standard position. Now, we talked about that yesterday. Where's the initial side of my angle? Good. It's the positive x-axis. Now, from what you saw above, and it's going to be clunky at first, and that's okay. How much of a circle in radians is a quarter circle? Sorry, let me rephrase that. How many radians is a quarter circle? Weird. Pi halves is a quarter of a circle. Is pi eighths greater or less than pi halves? Less. Now, if you're struggling to think about that, take the pi out. Is 1/2 greater or less than 1/8? Like 1/2 is way bigger, which means if a quarter circle of rotation is pi halves, I must still end in quadrant 1. I don't go anywhere near a quarter of a circle because pi fourths is a quarter of a circle. Sorry, pi halves is a quarter of a circle. So looking at this, pi eighths is rough or exactly 1/8 of half the way around a semicircle. Now it's weird because we're thinking pi ends here. Is this roughly 1/8 of the way around that half circle? Like 1, 2, 3, 4, 5, 6, 7. Like I'm obviously just not even paying attention, but it's roughly in here. I'm going to say that this right here is my alpha. That's my pi eighths. First question, why did I go that direction? I went counterclockwise because why? Quadrants, kind of. How do I know I go counterclockwise? What's the sign on this angle? Positive. And I think you were probably alluding to the same thing, just without saying, if it's positive, it's counterclockwise, just like the quadrants go, which is definitely what you were talking about. Okay, so as we see this then, if I wanted to, could I go around this way and wind up at the exact same spot? For sure. Now, you will not write it out this detailed every time. I'm going to say this angle right here is beta, because that's what we're trying to find, alpha and beta. So here we go. If you add these two together, do they make a whole circle? Like they must, right? Because that's how we get it. So just right now, we're going to ease into this. You just told me in more specific language that if you take angle alpha plus beta without thinking about the signs, they make a whole circle, right? And last little part, what's a whole circle in radians? 2 pi. Do we all agree that that must be the case? They form a whole circle, and if you need it, I'll just say whole circle. Now, I don't really care if we substitute first or if we substitute after, but if I know that those two angles together have to add up to 2 pi, and realistically, maybe I should have gone around the other direction because we still start and end at the same spot. It's just nicer to think about. If I want to solve for, we were given alpha, I must be solving for what? Beta. How do I do that? So do you guys want to plug in first or do you want to plug in afterward? And if you're not really sure, that's also an okay answer. If you're not sure, just so it's clear, help me rearrange it so we have beta equal something. Can I just subtract alpha from each side? So this is plugging in after. I haven't plugged anything in yet. I'm just solving it and then I'll plug in. We could have plugged in alpha here though. I'm not going to keep switching because it's going to be way too tedious. Just with this, I get beta is exactly equal to 2 pi minus alpha. Do you guys agree? And now, what was alpha? So 2 pi minus pi eighths, and it was yellow on mine, so I lied. I will switch colors. Can I do this subtraction yet? Why not? They don't have the same denominator. Could I make them have the same denominator? Which one? How should I rewrite 2 pi? 16 pi over 8 minus pi over 8 then, and we just made a common denominator. Can you tell me what beta is with some degree of confidence now? Sorry, it implies that beta must be equal to 15 pi eighths. And I agree with that. Now, the weird little part of this, depending on how I draw it, when I'm seeing this, what direction did I have to go for beta? Positive direction or negative direction here? Negative. So one way we can interpret this is we can look at it, and if we can all agree that if I start at here and end here, I had to go in the negative direction, what should this really be? Negative. Now, the easier way, maybe easier, we can either reason it out that it had to be negative, and we'll just say negative because clockwise, negative, and we'll just add an arrow, negative because, and I'm going to use this shorthand for because, it's this thing, clockwise. Okay, we can go negative there. Alternatively, is it reasonable to think that we could have looked and saw right away that it was negative? Like, can you tell it's negative here? Could we have, instead of doing plus, could we just called it minus beta right now and then solved it all the same? We would have got the same answer. We would have gotten the negative naturally showing up. They both give us the same answer. This one for me is more intuitive, but it is weird that we have to go and change something after at the end. Both work fine. Now, bigger question, even beyond this. Can we find another one? Are there more coterminal angles? If I go around anywhere from here, if I go another full circle, will I end up in the same spot? And any full circle beyond that? Does it matter whether I do that full circle clockwise or counterclockwise? No. So I'm just going to make the claim, and this is not really directly associated with this question because I just asked you to find angle beta, but there's literally infinitely many choices of beta. So I just want to make a note here. This works. This beta is fine, but turns out adding any full circle will additionally end me here. And how many radians are in a full circle? 2 pi. So I'm going to make a comment. Any number of additional circles. And I, working with the assumption it's a full circle, also works. Now, the way that we typically write these, and it's ugly for a second, if I want to say any number of something, I'm not being specific. Most commonly, one of two choices. Here, for any number of additional circles, we either use n or k. This book uses n. K is pretty common as well. But if I wanted to say n times 2 pi, how many circles is that? N of them, right? This is any number of circles afterward. And I could keep ending here or subtracting. As long as n is a whole integer, sorry, an integer, doesn't matter positive or negative, any number of full circles, I end at the exact same spot. Cool. They're kind of ugly. Let's try another one here. Okay. Questions here before I move on to another one. And what's weird about this, and I'll grab my notes here in a second, but I don't have my notes, so I know what's coming. Obviously, I know what we're going to next. So I'm trying to just really get some ideas just subliminally into your minds as we're thinking about them. Okay, let's try another one. What do you want alpha? What? Weird. What would you like alpha to be this time? B. Nobody's name here starts with a B, does it? Christina. Nobody's name starts with a B. What do you want alpha to be? Pi fifths? Oh, that sounded kind of negative to me, though. Let's say alpha is negative pi fifths. Cool. I want you guys to do two things. I want you to roughly try to sketch this out. And then I want you to try to find me, this time, two different possible versions of beta that work. Find two coterminal angles this time. Sweet. Try it out. Give it a go. We'll chat here in just a minute. Okay. Now, I don't really care which way we go. I do, actually. Alpha is negative. I lied right to your faces. I'm sorry. Because we're going from standard position. That means beta must be this larger angle right here. And what I know for sure is that if I add both of these up, and I'm going to try it the other way in case it makes more sense. Beta is positive or negative angle? Positive. And alpha is negative. If I add these two things up, what do they have to add up to? Like if we forget about the signs, they have to add up to 2 pi, right? Do you want to forget about the signs, or do you want to see it done the other way? I don't really care which way we go. We can either write alpha plus beta equals 2 pi, or we can try to work with the fact that alpha is already negative. So there was two options there, but that's okay. Let's try it this way. Alpha plus beta, guaranteed if you just take them, and I forget about the signs for now, it's a full circle. We all go with that? Now, maybe there's another way, and we're going to see another way. We're trying to solve for beta, right? So it's going to wind up being the same thing. Beta equals 2 pi minus alpha. Cool with that? Okay. Now, what can I plug in? Okay, so 2 pi minus, or do you want to change it to plus? What are we doing here? Plus. Why plus? I agree with you. Okay, so check it out. When we do this, I'm going to take one step. That is 10 pi fifths plus 1 pi fifth, and we get 11 pi fifths. So this would work for us. Now, it's not the only way. There's maybe a nicer way. If I want to start or end at the same spot, I just have to go how much? So like, let's say I'm here. I've already gone here, and I'm going to end here. If I want to end up at the same spot, can I do another circle? Or another 2 circle? Like, I can always end at the same spot. Would you agree? Okay, so check this out. If I want to end at the same spot, and I already know where it ends, can I? Go ahead. What direction is this? 9 pi fifths. 100% it's 9 pi fifths. So pause. Thank you for pointing it out. I don't know what happened here, but something got weird in my head. Why doesn't 11 pi make fifths? What? Why does, so before, Karina, I think you have it. You have the answer, so don't just shout it out, but you're good. I'm not faulting you for anything. Don't just ask Karina. Why doesn't 11 pi fifths make sense? Why should we all have noticed it right away? I didn't notice it. Karina did. Thank you for noticing, by the way. Why doesn't it make sense is a question at hand. Let me give you a second. Something weird. If I want to be able to end up at the exact same spot, how much additional rotation do I have to do? So like, check it out. I'm facing you guys right now, and let's say some amount of rotation gets me to face Abijah. I could turn that little amount of rotation, but I could turn different amounts of rotation also. How much more would I have to turn to get back to Abijah? So you tell me how many radians I've turned when I do this one more time. I just took my original angle and I added 2 pi to it, right? Could I do it again? Could I have, instead of adding 2 pi, because I just turned counterclockwise, could I have turned this way and also met Abijah at the same spot? So it turns out that whatever this is, it's always going to be a full rotation away from it. Do we agree? Now, this is going to give us a much easier way to do these problems. It's nice conceptually to see and think about these things adding up, but as just demonstrated completely unintentionally, it's easy to get goofed up. We're going to do one more, and we're going to make an important comment, and we'll just check it out. Let's pick this time alpha is just something wonky. Pi, I don't know, sevenths. I've never seen a pi sevenths gets used ever. Sevenths are ugly. Check this out. First thing, which quadrant is this in? So it's 1 or 2. I'm going to claim it's not 2. And like, if you're struggling to see it, pi is a full half circle. Okay, which means half of it would be 3.5 pi over 7. That's my 90-degree mark, or the straight up where I would change quadrants. If we cut it into sevenths, right straight up is 3.5 of them, half of 7. Is pi sevenths less than 3.5 over 7? Or 3.5 pi over 7? Am I losing you, Red? Okay, check it out. If this whole thing we call 7 pi over 7, because it's pi, half of that, do you agree is, yep, is this less than 3.5? The numerator, it's 1 pi instead of 3.5 pi. That's less, right? So I'm in quadrant 1. Now, as I look at it, I'm never going to care super specifically about where I am, but we're going to see a super easy approach to this that we don't have to worry about the signs. So I'm going to sketch it really quick, and we're going to go back to that same question that we left off on just a second ago. If I'm here, I'm just eyeballing it. Maybe that's pi sevenths. Right here, there's my lovely alpha. How much more do I have to turn if I wanted to wind up right there again? A full rotation. And a full rotation is how many radians? So say it all together so everybody can hear it. 2 pi. Real quickly, and there's not very many times that I do this because I kind of hate it, but every once in a while it makes sense. What's a full rotation? So that was really low turnout. Let's try again. What's a full rotation on a circle? 2 pi. And we're going to keep doing this until we get 100%, just so you know. What's a full rotation? 2 pi. 2 pi radians is how much of a circle? The full circle. So check this out. This comment, I want you to have this in here because I can tell by the looks in your eyes you don't love this idea, but that's okay. Check it out. We end here after any number. I'm going to say very specifically, after any number, and we'll just call it n for now, n additional circles. If I want to end at the same spot, give me some number of circles to do, and I can do it, and I'm still pointing in the exact same direction. Does that logically sound okay to you? Additional circles, or if you'd rather, rotations of 2 pi. Somebody in here is not comfortable with this thought, and I'm going to put you on the spot here, I hope. Who does not really, truly love what I'm saying right now? Check it out. I want everybody then. Let's stand up real quick. And here's my challenge for you. I want you to stand up, and we're just going to try something real quick. Okay, you guys keep facing forward, face the front of the room, and I want everybody then to physically turn your body and look at me. Now, we all have slightly different angles, just very slightly, but that's okay. Check it out. You've just been given my alpha, quote unquote. I want you to turn 2 pi radians for me. I don't specify the direction. I just want you to turn 2 pi radians. Did you end at the same spot? Now, if I said do it again, could you? And again, or do the other direction, would you still end at the same spot? If I said spin 30 circles right now and stop at exactly 30, would you still be facing me? No matter how many we do, right? So check it out. If I want to end up in the exact same spot, maybe there's an easier way to do this. I can simply add any number of full circles, which is any number of 2 pi, right? So let's just try this a different way. If I wanted to end at the same spot as alpha, because that's what beta has to do, it has to start and end at the same spot. I could simply start at alpha and add what amount of rotation? Any number of 2 pi, right? And it's going to feel uncomfortable, but I'll write it here, 2 or n times 2 pi, where n is any number. It could be 1 circle, it could be 3 circles or 5 or 10, it doesn't matter. It's that many n rotations of 2 pi. Do we all agree with this? And if you want me to make you stand up and spin a bunch of circles, I can make you do that. But I get dizzy after 1, so I'm pretty empathetic. Do you also? Like legitimately dizzy after 1 circle? Me too. Ugh. All right, so let's try this. What do we say alpha was? It's pi sevenths. Now, there's an easiest number of rotations. What's the easiest possible number of rotations? How many full circles should we go further? 1's the easiest, right? So let's try to go 1 full circle. So I'll just make a note, 1 more circle. And I guarantee we end at the same spot because we're going just an additional circle. If we took pi sevenths and I went one more full circle, how many radians would I have to add? One more time, much more conviction and confidence. That's right. We go 2 pi. This is one circle away. Do these combine, or can I combine them? And what do we get? 15 pi over 7. That was after one circle. Could I do it again? And I could do it again and again and again. We have found now a maybe nicer way to get beta without having to think about it all. Just go where you are and spin how much more? Once, or twice, or thrice, or 4 times. Now, what's weird about trig stuff is it keeps cycling back through. And we'll talk about the cycles of stuff, and like the tides get tracked with this, the moon's pattern, it's all trig. Any waves and any harmonic type of motion that does the same thing over and over, cyclical, can be modeled with this stuff. Is this the only angle beta that exists? No. If I said, and we'll just work this here, and I'm going to add a little bit to this. This is a positive beta, and that's okay. Could we do a negative beta and still end up at the same spot? Like, and just to show it, the one that we just found, it says start here, and we'll just go this direction to make sure we have the same angle being formed, and we do have the same sides of our angle. We could have gone the other direction, though. If I wanted to go in the negative direction, instead of adding 2 pi, what would I have done? We would have subtracted. So if we want beta to be negative, I'll just make a note. If we want negative beta, we could start with the same thing. Beta equals pi sevenths. And one more time, remind me, how do we make it negative? Full circle? Minus 2 pi. And we're still going to end at the same spot. We have to, because we've just done a circle the other direction. In this situation, and I'll show the fractions this time in case that threw somebody off. What's the fractiony way to think of 2 pi here? 14 pi over 7. And let's check. This would give us negative 13 pi sevenths. And maybe this one is realistically more natural, because the other one we had to go around a full circle, and it's okay, we still have the exact same angle. But the way that we drew it the first time when we were looking at our picture, this is almost a full circle, right? 13 sevenths, it's almost 2 pi. If I look at this circle going this direction, is it almost 2 pi? And I'm convinced now that maybe, just maybe, this is the easier way to approach this problem. Rather than really trying to think about it, if we recognize that it's always just another circle away, we'll just keep adding 2 pi as many times as needed, over and over and over. Okay, we should probably do one more like this. Here's my challenge. I don't want you to sketch it. Or maybe it's not a challenge and it just avoids any of the confusion. One of those. Okay, let's see. You guys are, which generation are you? You're Gen Z, and I'm the greatest generation. So let's say alpha. I'll make this fit your guys. 6 pi out of what do you think? 6 pi sevenths. I want you to find me, here's a challenge. For this one, you are going to find me my coterminal beta, but I want you to find me 2 of them. You are going to, from this angle alpha, find, and I'm not going to write a coterminal again, but I'm going to say find a positive beta and a negative beta. Cool. I'm going to give you guys a second. If you want to sketch, I want you to do it first. And then if we need to sketch it, I'm going to ask one quick question about it. Cool. I'll give you a moment. Yeah, you're good. All right. How's it going? Okay. We can expand on it here in a second, but I'm thinking and I'm hoping you get 20 pi over 7 is one of them. How on earth would I get 20 pi over 7? Sorry. Nope, my bad. 20 pi. Pi over 7. Why did we get 20 pi over 7? Yeah, we just added 14 pi over 7, or a full circle. Now, for somebody who's looking at that going, what the hell is going on? I don't understand. Here it is. If I want to end in the same spot, I just go how much further? 2 pi, or 4 pi, or 8 pi, or 6 pi, like any combination of 2 pi. Okay, and then we'll add one more step, 6 pi sevenths, plus there's a better way to write 2 pi here. And look at that, we get our 20 pi sevenths. And we're done. What don't you like? Christina, what don't you like? Is it about notation thing? If it is about notation thing, you need to be very vocal because... Karina, what didn't Christina like? So my assumption, and I don't always want to assume I'm terrible at it, is that you don't like the pi upstairs? Okay. Okay. So, how do I get the other one? Hey, I'm getting crazy. I'm wild. I'm going to subtract how much of a circle? 2 pi. Now, if I want it to be negative, is it going to shake out? I think so. We'll see. 6 pi sevenths minus 14 pi sevenths again. Hey, it totally does. Negative 8 pi sevenths. We have on the board right here 3 different angles that are in the exact same location. Now, last little thing, and again, no homework, and it is so against my nature because I want to give you a whole stack of these problems right now. But let's just check. You do not have to sketch this, but I'm going to draw all 3 of them. They all start here. Is this quite pi? It's 6/7 of pi, though, so check it out. Is that roughly 6/7 of the way across my circle? So here's where my yellow angle starts and ends. If we do the purple one, let's just try the same thing. If I start here, is this more than pi? It's a little bit more than pi, right? Like 1/7 more, but it's negative. If I start here and go just a little bit more than there, I end in the same spot. If I look at the yellow one, and I should have done that one, if I go 20 pi sevenths, that's way bigger, right? So here we are, check me out. Here's 14 pi sevenths, and now I need to go how much more? I just did a full circle if you didn't see it. 14 and 6 more sevenths. Hey, I wind up in the exact same spot again forever, infinitely many times until the end of time. Later, I'll see all of you guys in 15 minutes for the chess meeting. Informational meeting about Raider chess at 12:45 if you're interested. NHS people, we may have a short meeting. I'm waiting for Delilah to tell me if we need it or not. We might have a short meeting. Hold on. Okay, I was going to say don't leave without your phone. The stream quit like 20 minutes ago. I don't know why. Hello, Mrs. Holloway. Is it bus?
Stop.
Busing, bruh.
So you go up there and grab your phone.
So Christina was like, sorry to call you. No, why are you scared of just me? I understand not wanting to talk in front of everybody. All right. Okay, yeah. Do you want to go grab food first?
It's okay. I don't really much. So I'm good with this, but I need help with this because if I don't get this, then I can't get this. Unless this is wrong and I'm just...
You're going to hear. So, like, where are you struggling here?
I don't know where to get the number that goes here.
Take this and multiply it.
These two?
Yep. So careful. I'm going to, yeah, you're cool. What's 4, -4 times 2?
-8.
Write it right there. Now add straight down.
And then this would be -8.
Nope. Pause. Now you do this times this.
Oh.
We just kick through every time it takes a step further.
Okay. That makes more sense. So 4, 3.
Something weird happened here, though. I'm trying to see why.
Is it up here that I messed up, or is it?
No, it'll be fine because it's going to be this one. Okay, so here's the weird part. This is your 0, right?
Mm-hmm.
Let's see, I'm just going to double check. -8 is -1 and +4. Oh, there we go. What's 7? That's still not going to work. Why is it not going to work?
Do you need to look at it the right way?
Nope, I'm good. Cubed, squared, 1, 0. So no missing powers. 2, -7. Oh, that's what happens. -7. They're both -7s. And then let's erase the -1 and the 3. And then everything else will kick forward out of here.
Okay. So 15, negative 15.
Good.
15, negative 3.
So pause, because remember, this number, sorry, I didn't tell you to erase this one. This number gets generated by doing this, right?
Yeah.
So erase this 4.
Oh.
And then we have to multiply. And I'm going to hook you up real quick. It's negative 4 times negative 15 is 60.
60.
And again, we're still weird. And I don't know why we're weird. Because I'm expecting a 0 to show up here, is what I'm anticipating. I'm trying to see why it's not.
What does 0 show up in the 3?
I mean, we should have a remainder of 0, but I can already tell it's not going to happen. Positive 60, because you're going to write negative 53, right? 60 minus 7 is negative 53, and that definitely does not take me to 0.
That says 66.
Yep, so
I think, I don't know.
It should say 60 because we did negative 4 times negative 15.
Oh, yeah.
And that is 60, but I'm trying to see, and I just don't see why we're wrong. But we will. 2, negative 7 plus 30. And I claim that negative 4 works. Oh, it better work, because if it doesn't work, I'm in trouble. Or you're in not trouble, because it's going to make it so it's super nice.
Okay.
I don't love this.
The 4?
I'm wrong. It's not you. It is me that is wrong here. When I changed the question, something wonky happened. Yeah. Like, don't love it. And if you were here, I would say no, and I would make you redo a different problem.
Okay. So
I hate this. You get free points here. You love it, and I'm okay with it. You love it.
Yes.
Write it there on C. Let me see if D you can answer without it. Write free there too. You are the first person to bring that up. And weird that that's the case. That's not going to keep happening because I'm going to change it right now. But not for yours. Not for yours. I have no idea what happened on that. That's my bad. I'm sorry if that one's been stressing you out. I think from a student point of view, that's like the reasonable thought, just so you know. To say, like, thank God I didn't have to do it and I got the points. Like, no. I thought you were talking. Okay. You're fine. I'm going to adjust this eventually, but I definitely answer way too many questions on every test. But I'm not stopping it now.
I've tried this problem like 2 different times, and I don't know if I'm just using the wrong thing. Because this is...
Adam, you added these. Negative 50 plus 3 is negative 47, first of all. But what's 30 plus 9?
Oh, 39. I subtracted, I think.
Time, because there's another weird thing that happened. 30, or not. Like, these ones will work out anyway. 39. Yeah, so you're going to get a fraction. You're going to get a fraction.
It's okay.
You can change it to decimal if you want to. I'm fine with it. And you're welcome to...
I thought you were going to make me do it.
Oh, good. So I got it up there. Did you get a text from Delilah about stuff? The meeting and the shifts and stuff? Do you know what time you guys are playing? You guys aren't? Why not?